Right. Hello, everybody. It's 2 o'clock. I figure we'll go ahead and get started now, or maybe I'll sing a couple of show tunes while we wait for folks to come in. So my name is Scott Bly. Thank you so much for attending this session. I'm pretty excited to be able to be here in Rochester. I've never been before. So I'm appreciating the weather, ironically. And I live in Santa Monica, California, and it's always kind of ridiculously perfect there. So having real weather is a blessing. I appreciate it a lot. So I'm glad to be here with you all. And I'm really impressed with the quality of the conference. I haven't been able to attend any of the other speaker sessions yet, but the quality of not only the food, but the venue and the way everything's laid out is really good. So I appreciate what everyone's doing here. So thank you for your time and for coming to hear me talk about API security. So the thesis behind this is really kind of, adding API security to your DevSecOps Toolbelt. The idea is, how do you do that? What are the processes around DevSecOps? So say, for example, you already have maybe some DevOps tooling, and you have a CI/CD pipeline for your product release as you're putting software out to market, and your dev and your ops teams are working well together. You've already kind of accomplished that. And so you have teams that are accustomed to working together in order to get code to market fast. And maybe your teams are starting to talk about DevSecOps, and maybe you have some security testing happening in that DevOps pipeline, and maybe you've even accomplished part of a shift left strategy. But how do you really get the teams to work together? And how do you then, oops, why isn't my cursor moving? So you guys see that moving there. Oh, I'm on the wrong screen. There we go. Perfect, there we go. And if you're accomplishing that in your shift left, if you're starting down that pathway, APIs function a little bit differently, right? APIs are about how you consume code. It's about how you consume data resources. It's not necessarily something that's going to be a successful test in your SaaS environment, for example. If you're testing your traditional AppSec tooling, isn't going to pick up what's happening with APIs. Because APIs are about how you consume it, which is a different paradigm. So what we have is a different set of tools and a different set of expectations that we need to take on, and that's really what we're going to get to today. But first, let me talk about an agenda. So we're going to have an introduction, which I'll cover in just a moment, and I'm going to kind of set the stage for why API security. Why do we care? We'll look at DevOps versus DevSecOps to make sure we have a shared understanding of what those two are and what the differences between the two are. And then the technology, right? With anything that we're dealing with in security, it's technology, processes, and people. The technology is usually a tool set, so we'll discuss that. Processes and people will come up next. And then, how do you contact me if you have any questions, etc. So I'm with ISOA Group. I'm the director of the API security practice there. ISOA Group is a 27-year IBM partner, and now with No Name Security being acquired by Akamai, that partnership extends there as well. No Name has an IBM OEM relationship, and so IBM also participates with the No Name software in terms of adding API security to their API management portfolio, which ISOA Group has that long history of API management. They brought me in to stand up the API security practice, which I'm really pleased to be able to do. I was actually at No Name Security for more than a year before I left to join ISOA Group and stand up this practice. And prior to No Name Security, where I was deploying that solution to customers and helping them really operationalize their API security tool set into their environment and successfully get not only runtime, but posture management and testing data flow into their tool sets, and how do they really deal with the data they're getting out of it. Prior to that, I was at AWS, where I was a senior technical account manager, and I also ran the Enterprise Support Security Improvement Program for them, which was a program that looked at some of our largest customers and measured their holistic cloud security approach and gave them data about how they're consuming cloud resources and how they're securing those resources, as well as providing information so they can make data-driven decisions about how they should direct their resources and their investments into both tooling, people and processes, and how they're spending their time. So prior to that, I was a director of IT and cybersecurity. I've been a cyber consultant for about 15 years before that. So I've done a lot of things in this space, and I'm really passionate about the API security landscape that's really expanding and growing now, especially with No Name being acquired by Akamai. I think that really shows the maturity of the marketplace coming together. Now, Why API security? So what we have here is a pretty typical dumpster fire. I think we've all seen the headlines that are going. This is a pretty well-generated AI image from Canva, which is what I use to do these PDFs or these kind of PowerPoint presentations. And so I got a kick out of this. But really, what's happening is there's a cash grab on, right? And what we're seeing is, even Graham mentioned it this morning in his keynote, with the T-Mobile breach that happened, these are predominantly API breaches, right? And so it's everywhere right now. With the amount of data that organizations are trying to monetize, they're using APIs to accomplish that. And basically any organization that's large enough that they're building software, if they're using anything even approaching modern design strategies, they're looking at microservices, they're looking at those client-server relationships on a very distributed fashion, and that's all API calls. And as a result of those API calls, you have direct access to data. Once upon a time, if somebody wanted to pull a huge amount of data out of an environment, they'd have to go land and pivot and then figure out how to get access to either the file servers or, usually more importantly, the database servers, and pull those files out directly. Well, that's a mature space. So you have a whole lot of security around your databases, you have field level encryption, et cetera. And so what's happening nowadays when you have these sorts of breaches where you have 49 million customer records breached, you have 500 million records, et cetera, these are predominantly API attacks because API security is newer, it's less mature, and so fewer developers, fewer security teams know what to do about API security. And as a result of that API having access to both pull data as well as perhaps more scarily manipulate the data that exists behind that API call, you have an increasing amount of vulnerabilities that are exposed, as well as the result being the breaches that we're seeing in the headlines all the time. So there's a whole lot of problems that are happening, and it's kind of predicated upon the fact that DevOps has really been so successful, right? Most large organizations have a DevOps process now. You're putting code into the cloud, you're deploying infrastructure as code, and doing all these things that allow us to get code to market, to be able to deliver features and capabilities faster. Your marketing department saying, hey, we need to get this feature out by the end of quarter because that's what we promised our customers. We're counting on revenue for it, for this, that, and the other. And the developers are accomplishing that. And they're doing it in a repeatable way, which is what the DevOps success has been. But that speed to market has had an inverse relationship with the quality of the security capability that gets deployed. So you have this kind of exploding increase in vulnerabilities as well. So with data as the new gold, right? Has anybody heard that kind of phrase before? Or is that, yeah, so it's out there, right? Because of this gold rush that's happening, everyone is trying to monetize their data faster and faster and faster. And we hear about it with like Facebook, anytime you're using a free tool, you are the product yourself. Facebook obviously is selling your data. Google, same thing, right? So when you're paying for a resource, typically you have a greater degree of privacy expectation around that. But APIs are how these organizations are selling that. And every time we sign away our privacy expectations, when we do the acceptable use policy, I'm sorry, that's the wrong term, not the acceptable use policy, but the privacy expectation and the terms and agreements when you're signing up for a service, you're agreeing to allow that data to be sold, and it's almost always via an API. So as a result, you have this explosion in vulnerabilities, and you also have an explosion in vulnerabilities that are interconnected. Because if you have an API, that means someone else is consuming your data, which means your data is available to that third party, and what they're doing with that data is under less control of you as the data consumer or the data holder, right, the originator of that data, because what is their agreement with the environment or with the organization that you've placed your data into their trust, right? So this interconnectedness of APIs, especially with like low-code and no-code tools that are out, you have interdependent vulnerabilities that are compounding upon each other. So not only do you have an explosion in data consumption, an explosion in data access through APIs, but the vulnerability is expanding, and those are actually expanding exponentially as well. So the thesis here is that, what we want to do is resolve these vulnerabilities, but we want to do it earlier in the process, that's kind of what DevSecOps and what shift left is all about. Who's heard the term shift left before? Yeah, everybody. Okay, good. So we'll talk a little bit about that as well, but the shift left movement is important, but a lot of organizations haven't had an opportunity to get to that yet, right? They say, oh, we've got DevSecOps, or we're trying, or we're starting down that road, but they're not ready for it. And APIs, even within that context, are handled differently from a security perspective because it's a different method of access, right? So the other problem that comes along with this, even though you have organizations that are starting down that shift left process, you have a 1,200 to 1 ratio of developers to AppSec engineers. So how can the security teams, and we all see this in security all the time, right? You've got far more work to do than you can possibly ever get to, and yet your developers are still pushing code out faster and faster and faster. Does that sound true? Does anybody experience that? I'm seeing a lot of heads nodding. Okay. So the way that you address this is, of course, like anything else, technology, people, and processes. And what we want to do is we want to get to the point that instead of shift left and DevSecOps capabilities being included in your API strategy, instead of it being some massive project that's going to make everyone go, oh my God, how do I ever approach this? How can I take this on? We want it to be an iterative lift, right? You can do these things in simple steps that mature as you go along, rather than some kind of a terrible burden, right? Because that's going to make it just that much harder to get it done. And at the end of the day, your DevSecOps approach and the shifting left of your security effort, think of it maybe more like an insurance policy, right? Because when you accomplish this goal and you've managed to take care of your vulnerabilities earlier in your development cycle, you're hopefully never going to have the breach that we're spending so much time reading about and defending against and responding to, right? So you think of it more like an insurance policy, that you're making this investment ahead of time and you make it consistently, steadily over time in order to achieve that objective. So that's kind of what we're going to talk about today. Now, API security, this is, it's the no-name philosophy, but I happen to agree with it, so I'm borrowing this slide from No Name. But the way that they approach the software solution, I believe, is true regardless of whether you're talking about a software tool or whether you're talking about how do we approach API security broadly, regardless of what the context is, whether it's technology, people, or process. And number one is discovery, right? So if you can't see it, you can't protect it. We're all familiar with that phrase, right? If you don't know about an item, you can't possibly do anything to protect it or to secure it. So one of the things you want to do is make sure you have an accurate API asset inventory. And a lot of organizations may think, oh, I've got my load balancers, I'm sending the API traffic through, surely that means that I have an API inventory that's accurate already. Well, that's probably not the case. You probably don't have an accurate inventory because that's not really what that tool is there to do. It's there to route traffic. It's not necessarily there to give you an API management awareness that gives you that inventory. But you want to be able to have network mapping and reconnaissance capabilities that tell you what you have. Next up is posture management. I think of this primarily as vulnerability management, but it's also infrastructure. How are your APIs being delivered? Not necessarily about the code behind them, although that can be affected as well. So when you have configuration control, vulnerability management, and remediation prioritization, you have the ability to deal with those vulnerabilities. The next piece of the puzzle is runtime protection. This is where typically customers will start, is they go, hey, I've got all these APIs in production. I don't want to be the next T-Mobile. How do I deal with it? First, you have to have that discovery process, but runtime protection lets you know what's happening now, what's a bad guy doing, or what does your traffic really look like in the production sense. And last but not least is active testing, and that also happens to be the product name, but you're actively testing your APIs because it needs to be done in more of a DAS type solution, a dynamic application security testing approach, rather than static, because the code that's static in an API is really your spec file, which is fine. It's good to understand what that has and perhaps lint it, but active testing is about that shift left process and getting that into your CI/CD pipeline. Now, establishing a baseline. What are we talking about when we say DevOps? First of all, has anybody read the Phoenix Project? A lot of us. Okay, cool. If you haven't read the Phoenix Project and you don't already consider yourself a world-leading expert in DevOps, I strongly recommend that you read this book. It's fantastic. It's a novel about DevOps. It gives you a shared language. It should really be required reading for all of our teams. Anybody who has anything to do with DevOps or application development or cloud work or any of that, I am a huge fan of the book, and I recommend it to people all the time. But what it does, it gives you a shared understanding of what DevOps is and what it means. Now, the slide that I have here on screen is from the Department of Defense, which is also a really great resource for DevSecOps. If you just Google DoD or Department of Defense DevSecOps strategy guide. You can pull down a really great series of papers that they've written. And this is the image that I really liked that describes what is a DevOps software factory. How do we get code out to market in order to have it done in a controlled, repeatable way that moves things along faster? So this has been very, very successful, right? You have your code snippets and your scripts that are here that flow into an IDE. Your code repo then pushes out to a dev environment where you have a control gate, whatever that is, in your DevOps process. Maybe you have some testing. Maybe you have somebody just saying, hang on, stop, let's make sure everything's working in dev before we push it to the next environment. And your CI pipeline pushes it to test, and then you've got a CD pipeline that integrates it and puts it into a pre-production environment, and then you finally release that package. If it's in kind of the traditional like shipping on CD method, which nobody does anymore, but you put that file somewhere where a consumer can access it, or it's pushed and you have a real SaaS product that's updated on the fly, so you're getting the latest features to your customers in essentially real time, sometimes hundreds or even thousands of times a day, depending on the size of the organization. So DevOps has been wildly successful, even though organizations don't have necessarily a shared understanding of what DevOps means, which is why the Phoenix Project is something I recommend. But the net of it is that DevOps works, and organizations are using it to get code out faster. But like I said earlier, that speed has an inverse relationship to the security of your tool set of your product that you're putting out. And as a result, vulnerabilities are on the rise, right? We're seeing it in the headlines, et cetera. And also, as we all know, the security teams are all spread too thin. Does that sound accurate? Everybody's in security here. Are you all spread too thin? I'm seeing lots of heads nodding. Yeah, so it's true pretty much everywhere. And as a result of these problems, you end up with more and more breaches. You end up with reputation and financial impact, which is the stick that we wave around as security folks to get people to approve our projects and our budgets. And you end up with security team burnout. Is it still accurate that the CISO's average tenure is 18 months? Does that sound like that's still true, roughly? So you got teams that are burning out. You got people changing jobs because they can't take it anymore. Somebody else poaches them away, et cetera. And you also have teams that are really siloed as a result of DevOps. So the solution to that is maybe DevSecOps, where you start to integrate security processes into your DevOps pipeline, right? This is great. This is essentially shift left. The good thing about shift left, and does everybody know what shift left means? I had a lot of hands go up. Does anybody feel like they don't know what shift left means? Oh, you looked it up. Okay, cool. So I'll explain quickly. So if you think about it, code development in a timeline, in fact, it's shown here. So your code is moving from left to right as it ultimately makes its way into production. It gets written, they write about it, they go, oh, what are we going to do? You post it to your repo, it makes its way to the right where it's finally consumed. Think of it like a timeline from early in the process to later in the process. Once it's in production, that's all the way on the right. So you can think of that as kind of shifted right, but we all kind of start there by default because you want to know what's happening in production. Shift left means finding these things and dealing with problems earlier in the development cycle. The earlier, the better. If you can solve it at the, I have an idea I write down on a napkin stage, that's the best. But every shift, every step left in this process, that you can get to is an exponential decrease in the cost and complexity and time to solve that problem. So shift left is really important if you want your team and your security your security output to be more efficient. And of course, everybody wants that. So that's what shift left is all about. Now, many orgs are in the process of taking on that shift left DevSecOps approach, and they start here, which is good. There's nothing wrong with starting here. When you look at this screen, what we see here is the same image that we had before, where you have your control stages. What we've done is we've added testing stages to each one of these. So in dev, you may have unit testing, you may have code analysis on the SaaS side of the world, static application security testing, where you're looking at the code and you're saying, you've got a bad library that was consumed here, this is out of date, you've got a security problem here, you've got a hard-coded secret in your code that shouldn't be there, that should be outside of your code in a secrets repository that's separated. Whatever you find within your code, that's SAST. And then in your test environment, and maybe you've got system integration happening, and you've got DAST tools that are running for kind of traditional AppSec. And then you have acceptance testing and maybe penetration testing. That doesn't happen all the time in your pre-production stage. Maybe you've got a pen test once a year, every couple of years, per project, whatever it is. Each one of these are better than just dealing with your security in production, and they're all a step left. But there are still problems, especially when we start talking about APIs. And I'm just establishing a framework before we get into the API side of things more specifically. The main problem with DevSecOps when you're thinking about purely in a shift left model is it doesn't cover everything, and it's typically handled just through kind of traditional AppSec tools, right? So APIs need to be handled a little bit differently. And your dev teams and your security teams and your ops teams all have conflicting priorities. I was just talking to a guy at lunch about it today. Your dev teams are incentivized to get code out fast to meet the needs of the business from a finance perspective. Your ops teams are incentivized to make sure that that code and the feature sets and the infrastructure stays up. And your security team is there to make sure that risks are being mitigated appropriately and they're being handled appropriately. And those incentives are at cross purposes, right? So one of the things we'll talk about a little bit later are some ideas, and I'd love for you guys to be thinking about this incentivization process as we go through our conversation today. And if anybody has any questions, please raise your hand. I'm happy to have this be more of a conversation than just me yammering away at everyone. But think about that incentivization thing, because I'd like to have kind of an open discussion at the end when we get to Q&A, et cetera, around this incentivization problem. Because when teams aren't all working toward the same endpoint, the same goal, you can end up with unnecessary political friction in trying to accomplish what is really the shared goal of let's not get hacked, let's get those features out and accomplish this objective, but in a way that doesn't introduce risk to the organization. So incentives are a key way to accomplish that, and I've seen CISO panels where nobody has an answer for this, and folks aren't really thinking about it. So I think that incentive piece is really missing culturally from most organizations, and the more we think about that, about how to bring our teams together, I think the better off we all are. So a lot of times what happens is the security team is seen as like the organization of no. I want to put this thing out, I'm a developer, I wrote a thing, and you're telling me I can't do it, right? And so the earlier you're able to move into your shift left process, the better your collaboration between the dev and the sec teams is going to be. And right now there's still so much siloing that political friction exists. And as a result of that, you still end up with developers being restricted in their ability to accomplish their goal of getting code out fast, because if they get blocked late in their dev cycle, that's a problem. And the security teams have pressure to allow more stuff to get through that shouldn't, because it keeps the risk out, but the financial goal is still imperative, so the code has to go to market. So the earlier you shift things left, the faster you can catch it, and the more effective that process is going to be. But you still have the result of a lot of this when you're looking at it from a DevSecOps perspective in just the shift left side of things. You still have technical debt, because the more problems are found that still make it to market, the more technical debt needs to be remediated later, which is still expensive. You have security team burnout still, you have siloed teams, and it's still inefficient. So, or insufficient, I should say. So the next piece of the puzzle, this is also from the Department of Defense, is a DevSecOps lifecycle. And some of you, has anybody heard the term shift everywhere, security shift everywhere? Has anybody heard that? I'd heard it a little bit. It was a new term to me. I didn't quite know what it meant until I started really, really digging into preparation for this presentation, right? And in my view, the concept of shift everywhere is really about viewing your DevOps and your DevSecOps processes as this infinite loop that we see here. Let me go through it. So you've got essentially security introduced at every stage. And when you think about DevOps, you've got a planning phase, development, you're going to build it, you're going to test. We showed that on the previous slide where you've got your software pipeline that's being built, your software factory. And then once it's released, you then are delivering, and the operations team is responsible for deploying that code to your infrastructure. Maybe you have infrastructure as code, so that's very repeatable, but whether you're just deploying code that's a feature set, or whether you're deploying fresh infrastructure environments as infrastructure as code, and replacing those environments per deployment is another story, but it's still part of your deployment process. Then you're operating, you're monitoring your tool. Developers need to know from the operations team, is my application up? Is it performing well? What's happening? Do we need to throw more resources at it? Do we need more RAM per container? Like what's going on? And then you get feedback, and that feeds into your planning cycle again. So this is a really mature DevOps process, and sometimes you'll spin a few cycles on the dev side, and then while it's running, your ops team is going to be spinning it over here as they're watching for deployment, operation, and monitoring, and it feeds back and forth through this cycle. Now, when you look at DevSecOps, in that life cycle process, you add security to each one of those stages, whereas traditionally, what is mainly happening is people are thinking of DevSecOps just in that shift left process, which is important. It's a good starting point, but it's not the whole story, and you're missing out on a lot of the capabilities of what a DevSecOps culture can bring to the puzzle, can bring to your organization as part of that. So let's talk about these for a couple of minutes. On the planning stage, and I'm not sure, is the text big enough that you can read what's in the red shields here? No. Okay, so I'll narrate. Sorry about that. The first one here is threat modeling, right? Threat modeling is where you're looking at, here's my planned feature that I'm going to put out there, and let's say we'll use a simple web app as an example. I'm going to publish this web app as HTTP. What's the problem with HTTP? Anybody? Just shout it out. It's not secure, right? So what we need to do is we need to have encryption around that HTTP, so we're going to publish it on HTTPS so that we have a TLS tunnel that's encapsulating that traffic. That is something that you would arrive at when you're talking about how we're going to do this, because that's a threat model. If you don't have encryption around your HTTP flow, you're vulnerable to a man-in-the-middle attack when somebody can just come along and go, oh, I'm going to change what you're delivering, right? So that's part of a threat model. That's an easy example, but it goes on to things like authentication, and when you're talking about APIs, you're talking about authentication at scale, and from different sources, right? So you have different types of threats that you need to consider, and that's the threat modeling exercise. Then you have secure coding. This is probably the most important piece for developers, and a lot of organizations don't have like approved secure libraries. Larger organizations with a mature AppSec environment, AppSec culture, what's the word I'm looking for? Anyway, I'm blanking on the word that I'm trying to think of, posture, an AppSec posture. They'll have the libraries that are necessary for their standards to be adhered to for their secure coding practices. Next up is security as code. That has to do with how your security policies are being injected into the development process, right? So you can kind of differentiate, let's say, security protocols are a good example. As RSA is deprecated if you're hard coding your security into your software itself, so that, hey, we're using RSA is built into the application. It's harder to fix that later. Whereas if you kind of remove the security configuration itself and have that be separate, you have the ability to update that better and more quickly, so you can switch to like elliptic curve for your asymmetric cryptography if you have that separated out, so that the security as code is a separate piece than the code itself, right? So that your security is codified in a separate way, if that makes sense. Up next in the build process is SAST, so static application security testing. That's looking at the code as it was written, not as it's running. And what that does is it lets you know if you have out-of-date libraries, security problems, hard-coded credentials, things like that. Once you get to the test phase, you introduce DAST, so that's dynamic application security testing, which is really security testing that happens against a running environment. So the application is being used as part of that security process. Sometimes this is a human-driven process, sometimes it's automation. Next up is penetration testing, where you're throwing people or automated pen test processes against an environment in order to figure out what's there that maybe the tools didn't pick up on. Next up for release is digital signing, right? So you have to have your code digitally signed, and hopefully upon receipt, that digital signature is verified through a hash validation process. For example, Windows Update, that's all built into the application, so it's handled, but that's part of your secure release cycle. Once we get up here, we pass through the delivery phase. You've got secure transfer, so that's typically going to be either FTPS or HTTPS, however you're delivering that code to the end consumption location. Security configuration is about infrastructure, essentially, and it's also related. I was referencing the security policies for like your cryptographic suite that's used. If you're updating that and you have it separate as a security configuration location, you can update that separately at the infrastructure side. You have the same concept over here with security as code on the developer side, but those are two different pieces of the puzzle. Typically, that security configuration around the infrastructure is going to be handled by your operations team or owned there. Next up is a security scan. We're all familiar with like vulnerability scans running against tools like Tenables here, et cetera, Rapid7. These are all folks that have tools that check your environment for security vulnerabilities that you may not know about. Those obviously get added to your risk registry, et cetera, and you have to do the math of like, what's our exposure here? Do we want to fix this? Do we have time to fix it, et cetera? Security patching is the result of that calculation. Security patching, obviously, update Tuesdays, et cetera. The security patching is important, but is part of your operation phase. Next up is a security audit. Security audit, we all know what that is, validating that what you said you've done, you've actually done. Security monitoring, this is your SOC teams, analyzing logs, SIM tools, things like that. And last but not least, security analysis, where you're looking at what is the end result of all of this process that we have so that you can feed that data back into the loop again and you're back to threat modeling. So we've learned all these things about our environment. What do we think we ought to do? Let's go back and we'll address the next sprint where we're going to be releasing the next set of features, the next security updates, et cetera, and that starts the cycle anew. And sometimes you'll have multiple dev cycles and sometimes you'll have multiple operations cycles. So does this make sense? Okay, so what I'm saying is translating well. Okay, good. Making sure that I'm not leaving out any of the notes that I wanted to mention here. So the problem, though, with this is that APIs are a little bit different, right? Most of this is in consideration of traditional application security, where you're talking about the code and the features that are being delivered. APIs aren't necessarily about the data itself. So you have data security posture management that's an emerging field now. Obviously, simple things like we've all done when you're configuring a file server, making sure your permissions for the files themselves are set properly. That's the data. You have the code that's what's actually manipulating the data and doing the activities. But think of the API as more like the door, right? The way that your application is interacted with by a consumer, whether that's a person or another piece of code or another machine, whatever it is. The API is the way that that data code manipulation is accessed, which is a slightly different thing than the code that's doing the manipulation. So your API is then, in a best case scenario, is run through an API gateway. Maybe you have API management around it, but all of that doesn't necessarily address security. There are some vendors out there that are saying, oh, we have API security built into our product. Maybe that's kind of true. It's an important step in the right direction, so you definitely want to use the tools that you already have. But in my view, on that DevSecOps cycle, API-relevant security steps happen at only some of these stages. You could make the argument philosophically that it's everywhere, but for the simplicity of this presentation, what I want to do is focus on a few of them. Threat modeling, security configuration, security scan. I'm going the wrong way around the loop, but that's okay. Patching, audit, security monitor, security analysis, pen testing, and DAST. I'm mainly going to focus on 3 of those, which is going to be the DAST, security monitoring, and security scanning. We'll talk about that here in a few minutes. So when we look at how that works, we'll start with, again, we're going to talk about technology, people, and processes. Let's start with the technology side. This is that same DevSecOps cycle, but that's been exploded out into kind of more like a timeline, where you're going to go through each of those steps that we described before, and then it loops back, right? And in a DevSecOps consideration, you have security across all of this, hopefully automated so that you're not burning your teams out with more steps that they need to take. But what I want to do here at first, when we're talking about the technology, it's really about what tool set are you going to select. And that has to do with essentially the 3 that I've left labeled, the 3 arrows are DAST, security scanning, and security monitoring. So on the dev side, you have a lot of API scanning tools that are available on the market that you can integrate into a CI/CD pipeline. That's very, very good. But in order to really test, you typically need to have a live environment, whether that's a dev, test, or a stage environment that you want to test again, that's up to you. But that testing of an API needs to happen at the DAST side of things rather than SAST, because the API is about consumption. It's about how is your code being consumed and how are users interacting with that code and what happens as a result of that. And that's more of a dynamic process. You could have some SAST analysis around your spec files, but I have yet to see any customer anywhere that is actually doing that. So that's kind of a separate issue to consider. I would argue that it's more important to have your DAST piece of the puzzle addressed first. And then once the API security space is more mature, then maybe adding SAST scanning to your specs as a separate piece of the puzzle can happen. Some tools do both. So when you are injecting that DAST into this environment, that's where that's going to happen. So security scanning of your APIs before they make it to production happens at this stage. Again, the security has shifted everywhere in this model, but what we're doing around monitoring is there are two things you want to monitor really. The runtime piece I talked about earlier, and then also your posture management. You need to understand as your APIs are updated and as your code is updated to reflect what's necessary to remediate the API problems, the change across your environment needs to be tracked as well. So you need to monitor whether or not that behavior still exists. And I'll talk a little bit more about this in a few minutes. Any questions about this so far? We're really talking about the technology piece, which is security testing, security scanning, essentially for vulnerabilities, and security monitoring, what's happening in real time. Does that make sense? Okay. Oh, yes, question, sir.
Yeah, I have a question on the last slide. Where do you see architectural analysis coming into this?
Let me go back to this one because it's a little bit easier to describe here. I would say architectural analysis happens here around threat modeling and at the conclusion of everything you've got running. So say you've got an environment that's already up and running, you want to determine what do we know about the environment that we have running, what changes do we want to make, and that feeds into the planning stage, which is really where architecture needs to be considered most strongly. So threat modeling and the security analysis that feeds into the threat modeling. I would argue that that's where the architectural piece comes in. And then, of course, you have the infrastructure side as well, which is about security configuration. But your architecture needs to be determined up front. And for example, when we're deploying an API security tool, it's all architecture discussions, right? What's your end state that you want to get to, and how are you going to get there depends on the architecture that exists. So you have to have lots of architectural discussions around how the tooling's going to work in order to then stand it up and have it give you the result you want at the end of the day. But that same concept applies to when you're deploying features and you're deciding how you're going to build something. That architectural piece needs to come as early in the process as possible. Just at lunch today, I was really impressed. The gentleman I was sitting there eating with said that his developer teams have a security person attached to every single project, which is a best case scenario, that they're involved from the imagination stage. But it's rather uncommon. So I was actually really, really impressed that he said that. For those of you that are working with your developer teams, we'll get to more of this later when we talk about the people side of things, but get your security team members to have communication openly with the developers. It's going to make life much easier for everyone, and it's going to reduce risk more aggressively and more efficiently than if you didn't. Okay, did that answer your question about architecture? Sort of? Okay, let's get to the end, and then if you have more, we can certainly dig into that a little bit deeper. Next up, so when we're talking about technology, I know in this particular presentation we're not supposed to have any logos. So what I did, I just put up all of the logos. This is, let's see, who published this? API Landscape. I think it's apilandscape.io or something like that. But if you just do a look up for like API Landscape map, you'll get this. This is obviously insanity inducing. Who could ever possibly absorb all of this? So this is the API landscape and all of the vendors that are involved. But if we look at security, this section right here is security pure plays, is how they've described it. Even that is so enormous of a field. This is not security related. This is, hey, we're an API related firm that's doing a security focused activity. Even that is so overwhelming. How can anyone possibly absorb all of this? How can you decide what tools to go with? So knowing that that's the case, that this ecosystem is exploding, what I did is I went to the OWASP website where they have an API security tools list that happens to have been published by a guy that I used to work with at No Name. His name is Matt Tesoro. He is amazing. If you don't know Matt, look him up on LinkedIn. He's at I forget the name of the company he's at now, but he's part of the OWASP API security top 10 committee and all that kind of stuff. The guy's a ninja. So his list of security tools I used, and I kind of parsed it because I thought, all right, so we're not talking about vendors here, otherwise I'd be talking about the main solution that we like to deploy. But when you look at the tools that are out there, just the ones that are from the OWASP side of the world, as far as the ones that they have awareness of and that they've kind of discussed, there are 56 tools in total that have to do with API security that deal with posture, runtime, and testing. 36 of them are commercial, 20 are open source. Now, when I look at the tools and what they have, there's lots of testing available on both sides of the fence. So if you're trying to decide, hey, this API security thing sounds like it's important, how are we going to approach it? It depends on what your objective is. If you already have a mature AppSec culture and you have good processes in place, then perhaps adding testing to your existing mature AppSec universe makes a lot of sense. And if you don't have budget, then open source to add API testing tools can make a lot of sense, because presumably those are going to be available at low or no cost, and you just have to have the engineering team ready to be able to deploy that solution. Of those open source tools that do testing, only one of those has a posture component to it. On the open source side, there's only one posture tool and only one runtime tool, and of those, only the posture tool has an overlap with the testing component. So if looking for what bad guys are up to now is a concern for you, or if vulnerability management in what's happening in runtime, your running posture, is a concern to you, then open source has a, let's say, a smaller number of options that are available. On the commercial side, there are 13 posture tools, 13 running tools, and 35 testing tools. So there's an overlap between those. Only one of the posture tools does not have runtime, and only one of the runtime tools does not have posture. So it seems like there's either 14 or 15 total tools that are concerned with posture or runtime, and a lot more commercial tools for both testing, as well as the ones that include kind of a, we'll call it a full suite of services, from posture, runtime, and testing all included. Obviously, I believe all of the major players, there are about half a dozen that are considered kind of the leaders in the API security space. I won't name names, but I believe most, if not all of those, have the full suite. Now, generally speaking, so I mentioned we're an IBM partner, and some of the IBM sellers have asked me, oh, when should I be talking to customers about API security? And my answer to them is, not always, but generally speaking, if an organization has a developer team, even if it's outsourced, if you're creating software, then odds are extremely good that you have APIs, right? Because APIs are how microservice communication takes place. It's how you order an Uber on your phone. You may not know it, but all the things that are happening on the back end, those are all API calls. API calls account for, I believe it's something like 60 to 70% of all of the traffic on the internet. So all of your cloud environments, those are all API calls, especially all the configuration side of things when you're sending commands to the cloud. So there's a huge amount of API relevant activity that's happening. But basically, if you have a developer team or you're publishing software, odds are good you have APIs. Therefore, you have API vulnerabilities. I have yet to see a single customer, ever, when you stand up an API scanning tool, whether it's in the shift left, runtime, or posture side of the world, where there is not a problem. Has not happened, not once. And I've been on dozens of customers myself and hundreds of customers across the teams that I've worked with. It has never happened. Even when you're talking about security organizations, financial institutions, insurance companies, healthcare, that's why I use the image of a dumpster fire. Nobody is doing API security well. It's just too new, and it's too fast an explosion in growth. So the other thing to consider, yes, you may have APIs. You may have API vulnerability that you know about, but in my mind, there's a prerequisite to dealing with API security, and I think that that's really, it's kind of twofold. Most every organization is going to have some kind of a security department that has a SOC or something happening. Somebody's responsible for security. And the real prerequisite, I would argue, is that you should have an AppSec process in place. You should already be doing the basic, mature application testing that we saw in the first DevSecOps pipeline process that I described, where you're doing static analysis. There are very few scenarios that I can think of where it makes sense to deal with API security without having already achieved that step. It can be immature. You could have just rolled it out, but I think you should do that before you're dealing with API. So when you're doing that, the next question becomes, what should you be looking for in a tool set, right? So this is an example environment. I'm not going to tell you which vendor it is. You can probably guess, but I'm not going to say what it is because I'm not trying to sell anything here. But it's a good example of what you should see. So remember, we talked about the 4 pillars of API security. Those fundamentals are discovery, posture, runtime, and then that testing piece. What we see here is an inventory. So this is an example of what you would get from a discovery process. You see your hosts, you see the paths that are involved with each one of the APIs, maybe the ports that are involved, what method is there, and what do you know about the tool, right? The tool should be telling you, do you have risk? What authentication is being used? Is it internet facing? And if so, what protocol does it use? So we have, in this particular example, this is an HTTP call. It's not an HTTPS. If that's a problem for that application, you want to know about that. And most of the time, organizations have no clue what APIs they're even running. So are there security findings? Are there security incidents, et cetera? So this is what you should look for from a tool around inventory. This is an example of a vulnerability that's been identified. You need to understand your inventory before you can get to this, because your vulnerabilities are about an item in your inventory. But this is saying, you know, an API accepts an expired JOT token, right? What happened? Is there a particular time? When did we see this? And what should we do about it, right? If your tool isn't giving you guidance, what good is it, right? You want something that's going to tell you, how should I address this? It happened because somebody doesn't know what to do correctly. So now that we have this guidance, what do we do with it, right? So you want to see that. So this is both on the posture side as well as on the testing side, where you would see a vulnerability that's discussed like this. On the runtime side, you want to find a tool that's going to do something that's going to tell you when something happened in a runtime environment if there's an incident, right? Maybe it's a real incident, maybe it's not. There's false positives in every security tool. But if you're looking at runtime considerations, then you want to know what happened, when, and by whom. So here we have a view of a security, you could almost think of it as like a SOC light, where it's saying, here's a bad guy that did a thing, and here's all the activities that they were doing. This is what they were up to, right? You want a tool that's going to give you that kind of visibility, because that can then integrate and feed into your existing security apparatus, like your SIMs, your SOARs, your SOC team can get access to this kind of data. And your vulnerability remediation team needs access to that previous information here. They want to know, hey, what are the vulnerabilities we have out there? And maybe you're alerted to a vulnerability because of something that has happened already. That's that shift right side of things. Or maybe it hasn't happened yet, in which case it's just a vulnerability that hasn't been exploited. But those need to get routed to the right teams to be able to deal with it, right? So that you can feed that back into your planning stage, so that you can develop and update your tools, your code, so that you get those things remediated. Now, that's the technology side. Now let's talk about processes, and I'm starting to run short on time. I tend to talk fast, so I may talk even faster now. Around processes, in my view, the pieces of the API puzzle that are process-driven, not technology-driven, are penetration testing. Each one of these things, you could make a philosophical argument that the opposite is true, right? But from my perspective here, I'm going to argue pen testing is mainly process. When does it happen? How does it happen, et cetera. Security configuration, also process. How does your infrastructure get set up? That's a process that you need to have in place to be able to deal with it. Security patching, also a process. Update Tuesdays, for example. Security audit, definitely process related, although there's automation around that as well. And then on this side, you have the security analysis that we talked about and the threat modeling, which is around architecture. These are all process-related pieces of the DevSecOps puzzle, but you need to be doing all of this to have the complete cycle. But it's important to know that you don't have to do all of it all at once. Remember, I mentioned this should be an iterative process, not some big, huge burden. You identify what's most important for your organization to tackle, and then you do that. And once you've got that going, you go, okay, what's next for us? It's the same process you do for any security remediation process that you need to do. But don't try and boil the ocean. You can't do it. That's a recipe for failure. You identify what's most important for you, and you add that into your existing processes. Now, last but not least is the people side of things. And this is another ridiculous AI-generated image. I said, I want an image of hackers around a campfire singing Kumbaya, and this is what it gave me. Now, what's interesting is that AI thinks that you should be roasting a laptop over the fire, which I'm sure is not as delicious as s'mores, but you know, hey, maybe in AI world, that's what that should be. Some of these were nightmare-inducing, so I didn't share those with you guys, but this one I thought was pretty good. Now, on the people side of things, the thing that I like about API security is that it exists at the intersection of kind of the DevSecOps triad. You have your dev teams, your security teams, and your operations teams that are traditionally siloed, which is a big fat bummer, but when you're talking about API security, it addresses all three. The developers are the ones who have to fix 90% of the problems. The number of problems that are identified in an API environment that are fixable by the operations team, i.e. infrastructure, or maybe your encryption algorithms that are being used, whatever, only a few of these things can really be addressed by operations. But they have to be involved because they're running the infrastructure that's there, right? And the security team typically owns the tool and is informing both the dev team and the operations teams about what vulnerabilities need to be remediated, and it pulls all three groups together. So that's what I find really exciting about the API space, is it pulls those teams together very organically because the developers are alerted to the problem. The same as with your AppSec tooling, right? Developer has to get this into their next sprint, whatever it is. The security team provides that guidance. But with traditional AppSec, the operations team doesn't necessarily need to be involved because it's just code that's getting fixed, right? APIs are about running code, which is a slightly different process. So you kind of really pull all three groups together. I'm not saying there aren't things out there that also pull all three groups together, but API security really does. So on the people side of things, what we want to do, the problem is everything we talked about, you know, with the silos and the security team burnout, and the skills gap, right? How do you address this? Number one, break down the silos. Let's start by establishing a DevSecOps center of excellence, right? Thank you. Let's make sure that we have co-hosted technical trainings to address that skills gap and get teams to collaborate better. And I'm a big fan of, you know, what we did last night, right? At the end of the formal part of the conference, everybody got together for a couple of beers or whatever it was. Get your teams together. Put your dev teams in touch with your security teams and your operations teams and just mix them up. Get them to go communicate and have a rapport with each other. So instead of the security guy being the one that's like, hey, he told me I can't do that, it's his buddy Pete that he meets every couple of weeks for pizza or for lunch or the trivia virtual meeting that everybody does on happy hour on Friday virtually, whatever it is. But get your teams together and cross-pollinate them so that they have a rapport, so that it's not this us versus them mentality. And last but not least, I mentioned the cross-incentivization. We've got a few minutes for Q&A. This is really the end of the presentation. But that cross-incentivization piece, you got developers that are paid and bonused on getting features to market as planned, right? You have operations teams that are incentivized and bonused on did your app stay up, and security teams that are there to reduce risk and to remediate vulnerabilities. But those three things are all pulling on different sets of resources and have different operational constraints. So one idea that I've heard thrown around about how might you cross-incentivize, you know, your developer teams have a bug budget, perhaps, that is being used to determine how many bugs are okay to have in your code before it can go out or whatever that process is. I'm not myself a developer, so I'm not familiar with their kind of internal machinations, right? But if you have security remediation as part of that bug budget, that might be an idea of where you can start to create those incentives that are pulling the teams together so they're working toward the same goal financially for themselves, right? I'm worried about my job and keeping my job, not whether the security guy gets to keep his job, right, if I'm the developer. So you want to pull those teams together. I'm going to pause there, or actually I'm going to stop there and, you know, open it up to Q&A. We can talk more about architecture. I'd love to chat more about the cross-incentivization piece, but also you can contact me at my email address there, sbly@isoagroup.com. ISO group, again, I mentioned API management, API security, all things API, we're happy to help. Reach out to me on LinkedIn. I would love to stay in touch with anybody who's interested. Thank you so much for your time. Does anybody want to ask any other questions or talk about this cross-incentivization piece, for which I don't have a fantastic solution, so I'd love ideas. So in my next presentation, I can throw out some other cool cross-incentivization ideas. Any questions? Did the architecture piece get addressed to your liking? Sort of, well enough? No?
Yeah, I guess my big concern is just making sure that threat modeling actually gets adequate attention in the process. And it's, I've heard the stat that more than 50% of the issues shipped to a software are actually architectural flaws.
Yeah.
That are not represented in the code.
Yeah, absolutely.
That's really where I see a lot of the traditional SS,
Yeah.
DLC.
Yeah. Thank you so much for everybody for coming. Yeah. Yeah, I agree. I think architecture is a big piece of the puzzle, and threat modeling is how you get to that. And unfortunately, it's a step that gets skipped, right?
It just doesn't get the attention.
Yeah, I agree. Yes, sir.
Just to add to his point, to incentivize, you could potentially make a case that threat modeling, identifying that bug, that security flaw, is actually going to save you money.
Oh, huge.
Because you're not going to your backlog, building that tech debt.
Exactly. That's exactly right.
I had a question: how do you get teams to start threat modeling? Is that something we're bringing up? Hey, this all this cool stuff, and you should do it. They're like, no, not doing it.
You just need to build build a step into their process that is required, right? If you haven't done a threat model, what's that?
Like a story, like you need to threat model.
Yeah, I would think so. If it's just part of the process that needs to be there, then people will start to do it. Even if they're just like rolling their eyes and checking the box, okay, yeah, I did a threat model. That's better than nothing, and it starts to build the expectation. And then when you have your threat model review, like, hey, we're going to go talk about threat modeling. Everybody that says you did your threat models, let's look at what those look like. And start with the carrot. The team that did the best model gets, I don't know, free lunch or a trip to Tahiti, whatever, right? But start with the carrot. But that's a great example of that incentivization, right? Your teams aren't doing threat modeling. How do we get them to do it? Get the people together, get them to start talking about it, socialize it first, and then you build a process, right?